little bit further away so the screen to be kind of visible. I don't know if it is possible at all.
No, I gotta,
No?
I gotta move it up there. If you
Oh,
project on the screen.
oh,
But I can move it when you project
okay.
on the screen.
Well, it depends if they don't ask. If you guys don't ask for homework questions, the homework is due tonight.
Oh, I was gonna ask about question 16
Uh,
when we get started.
yeah, well, the way to ask for a question or a problem, if it is a homework problem, just write the number. If it is some other problem, you have to show it to me. And actually, it is a good opportunity, right? You to offer problems from the midterm. It doesn't need to be homework. It doesn't even need to be from our textbook. If you encounter, if you find a good problem, you can write actually your entire midterm this way. Just find a good number of problems related with the material, preferably, that we're discussing, and we're going to solve them in class, and we're going to announce that those problems are going to be in the test, and here it is, you have the test done. So talking about tests, the first midterm, we have to do it after we finish chapter 20. So the first midterm probably is going to be the week after next week, after this coming week. Next week, and we have to agree for the day. And since many people, we have an online class, you have an option to do the test here in class, or you're going to have an option to do a test online from 1 o'clock to 1:50. If you want to do it in class, you have to come to our 11 o'clock class, from 11 to 11:50. And here in class, you're going to have proctors, or at least one proctor is going to be available, which is myself. If you're online, you shouldn't use the help of I don't know, Google or chat rooms or anything. But you have a choice for the homework assignment. The homework assignments are going to be a source for the midterm problems, and I'm going to post. I have to write down a practice test, and I'm going to do it. Next week, you're going to have a practice test posted. Yes.
Did you say if we wanted to take the test in person, we had to come to the 11 o'clock class?
Yes, please. Yes, because I cannot handle simultaneously online and in-person classes. This is why you just have to. There is no, well, people are going to ask questions online, and at the same time, I have to answer questions here in class. Just not easy to do. Yeah.
So if we have classes, then we're just.
If you have other classes, talk to me and we can arrange alternative if you.
But we do have the option to take it online from 1 to 1:50 if we can't make the morning, right?
Yes, absolutely. Yes. Yes. Well, it's your choice. Yes.
So I won't be able to come to 11 o'clock either because I have lab. So is the 1 o'clock test online? Do you use the Zoom? Do we get on the Zoom?
Yeah, it is going to be on Zoom, like so. Yeah, we haven't had, we don't have experience how to do online tests, but basically it is going to be for the online test, you have to log into Zoom. I'll send again the login info, the link. You have to log into Zoom, you're going to get by email. You're going to get the questions by email. You have to write solutions and solve the problems by certain time. And then you have to spend a few minutes to scan your work in a very readable way, because sometimes scans can be tricky, in a PDF format. So make sure that you have an app that converts into PDF, a single PDF file, and email it by certain hour. And after that, it is going to be, well, that's it. This is where you. So during this online exam, you have to be on Zoom with camera on, so proctors to see you and to make sure that it is you that you're taking the test rather than some Indian or Chinese guy from the other end of the world, right? But again, you don't need to do anything.
You had a question. How will online test takers access formula sheets?
The formula sheet is going to be a list of formulas are going to be provided together with the questions. So you don't need to use any additional materials. If I forget to write a formula, you have to send a question describing which formula you need and you don't find it. And you send it via the chat option of the private question to whoever is proctoring. And then or the proctor is going to write the formula and send it to everybody. So if this happens, but again, formulas. Yeah. Okay, other questions there?
This isn't about the exam, but they're asking if we could do homework 18 and 22.
If we can do homework, which?
Homework problems number 18 and number 22
Okay.
later in class.
So what we have 16, 18, and 22. Is that right?
Yep.
Okay. Okay, let's start then with, yes.
One last question about the homework. It says that the next homework is due on Monday.
I think I changed the deadline. So look, the original deadlines are optimistic. I want people to feel kind of comfortable with the material. Otherwise, I can really, I don't want anybody to feel that things are happening very fast and nobody has well, you need to have the time to think about the material. And well, let's start with the homework assignment. All those problems 16, 18, and 22 are from chapter 19 homework assignment. And let's look at those questions. So I was trying to start chapter 20 today, but we probably won't be able to because in the first section of this class, people had so many questions that I had to answer those questions rather than start the new material. But let's do the homework first, and after that we're going to discuss. Oh, okay. So let's start with problem number 16 from the homework assignment on chapter 19. Yeah. Okay, so homeworks problem problem 16. Oops, right here. So this is a problem that so you probably don't even remember those bulky TV sets that we had in the past, but they were really bulky because the picture was produced with a TV picture tube, which is practically a device that accelerates electrons to high speed. Those electrons hit the screen, and this hit produces a scintillation, a flash of light. Eventually, multiple flashes of light very quickly form the image that you see. So this is how those old TV sets worked. And in this problem, well, you have to accelerate the electrons to speeds high enough to give you a good bright flash. And those speeds are relativistic. And since we don't know relativity yet, they tell us, make the calculations in a classical way without taking into account the relativistic corrections. So the numbers that we're going to get are reasonable numbers, but not exactly accurate because the relativistic effects are not taken into account. Look, this entire problem is based on a single formula, the formula that tells you that the work done by the electric field to move a charged cube from point that has one potential to a point that has a different potential, that work is equal to the product of the charge times the potential difference between the 2 points. And the potential difference, I will use the letter V for voltage rather than delta V, just because it is a standard and not very accurate, but easy to use notation. So this is going to give you the work done by the electric field when the charge moves from a potential that is certain number to a potential that is a different number. V is the difference between the voltages at the 2 points. Q is the charge, and this is the work if you use for the charge, if you use coulombs, and for the voltage difference, if you use volts, the result is going to be the work in joules. So this work of the electric field is converted completely into kinetic energy of the charge. So for problem 16, you're given the voltage difference between the 2 points. For my version, this is 23,300 volts. You're told that it is an electron and the charge of the electron is known. It is a number that is one elementary electric charge. So take the absolute value of the charge and the absolute value of the voltage difference between the 2 points, and you're going to get the work done by the electric field up to algebraic sum. So you have this, the work is elementary charge 1.6 times 10 to the negative 19 coulombs times the voltage difference. For my version, it is the number on the screen. For your version, it is going to be a different number. And take into account that work is exactly in magnitude. Here, I'll put that. So this magnitude, this absolute value sign, takes care of the negative charge of the electron. You don't want to deal with positive, negative numbers. This entire work is converted into kinetic energy of the electron. So it is converted into 1/2 mv squared, where v now is the speed of the electron. M is the mass of the electron. Again, you have to take it from a table in the textbook or from Google. So this is your equation. The product of elementary charge times voltage difference gives you kinetic energy of the accelerated electron. And now solving this equation, getting rid of all minus signs and solving this equation for the speed of the electron, you have the speed of the electron you're going to get to be equal to square root of 2 times elementary charge times voltage difference divided by the mass of the electron, and this should be your answer. So when you plug in the numbers, when you plug in the numbers, you're going to get some speed that is quite long, quite large number. Well, I don't know exactly what speed you're going to get because you have to do the arithmetic here. But it is going to be a speed of the order of the speed of light in vacuum, and this is why they say relativistic effects have to be taken into account in order to do this accurately. Let's see questions and remarks. So it is a lot of talking for a simple formula, but this simple formula tells you how to handle questions related with work and energy. This simple formula, product of potential difference and charge. By the way, if you calculate only the work done by the electric field using this formula and using the charge of the electron, even though the voltage is large, it is 23 kilovolts or this order of voltage. It's high voltage, it is thousands of volts. But the electric charge, elementary electric charge, is very much smaller. The result is going to be work in joules, a very small number. It is going to be a number of the order of thousands of a billionth of a joule. So this is why using joules for measuring amounts of energy related with energy that electrons acquire, let's say, particles with small charge acquire, using joules is not a good, not very convenient unit. So very often, instead of joules, as you're going to see at the end of the semester, we use electron volt as a measure of energy. And electron volt is the energy that one elementary charge acquires when it moves from between 2 points that differ by a single volt. Potential differs by a single volt, 1 volt. So 1 electron volt energy is going to be equal to 1.6 times 10 to the negative 19 joules. So if you plug in here an elementary charge and plug in here V to be 1 volt, you get the work or energy acquired by this elementary charge when it moves between points that differ by a single volt potential is going to be this number of joules. So 1 electron volt is this. And the atomic scale usually is given in electron volts, almost never in joules. Okay, questions, remarks? If not, let's go to problem number 18. Let's see what's problem number 18 from the homework assignment. Okay, so you have a point at some distance from a point-like charge, presumably, with given value. And you have another point that is at a different distance from that charge. What is the potential difference between the 2 points? Okay, yeah, this is simple, but at the same time, important question. So here it is. So here is your point-like charge. So the value of this point-like charge is negative. For my version, negative 2.11 times 10 to the negative 9 coulombs, negative 9 coulombs. And you have the point A is at this distance. Here is point A at distance R1 equal to, for my version, 0.22. And point B is here. Point B is at the distance R2 equal to, for my version, it is 0.49. 0.49 meters and meters here. They're asking us to find the difference between the voltage at point B and the voltage at point A. In this problem, they don't remind you, but you always keep in mind that the calculations that we do are valid under the assumption that the voltage at infinity is 0. So now in this, look. Now in this, you say that, well, the voltage at point B is going to be given with the standard constant K. It was of the order of 10 to the 9th, I think, or 10 to the 8th, times the value of the charge Q. For me, it is a negative 2.11 times whatever, divided by the distance to point B. It is the distance R2. Similarly, the voltage at point A is given by a similar expression. Just the distance now between the source and the point of interest is a different distance. And here are your two equations. You subtract the second from the first, and this forms the voltage difference that they're asking. So you get VB minus VA is going to be this minus this, which you can write in a shorter way by factoring out the common factor Q times K, and in the brackets you have 1 over R2 minus 1 over R1. So keep in mind the algebraic signs. Since R1 is smaller than R2, the result is going to be a positive number. But you have to calculate that number to figure it, to get the value. Use more significant digits. WebAssign requires your answer to be within 1% of the exact correct answer. Okay, questions? Okay, if no questions, let's go to Oh, is it positive or negative? Let's see. So this is a negative charge. So in the brackets, you're going to have R2 is larger, so R2 is going to give you negative, and the result is going to be a positive number, at least for my version. Okay. Questions and remarks? If not, let's go to problem number 22. Okay, so this problem is about capacitors, and actually it is a problem related with biology. And look, we're going to talk about that when we have a chance, but keep in mind that it is clear at this point that electromagnetic signals are very important for biology, starting, of course, with the functioning of the nervous system and ending with tissue differentiation. Not only chemical signals rule in those processes. Electromagnetic signals are also very important, and unfortunately, this is an area of biomedical sciences that is not well understood. It is a research that is in a process, and actually, the reason for not knowing exactly the electromagnetic effects in biomedical phenomena is that very often physicians and biological researchers don't have a very good grasp of physics. As simple as that. And the physics actually is much simpler than the chemistry, but you need to know it. So let's solve this problem. It is practically a problem that asks you to find the capacitance of an axon, part of the neuron. And look, so again, last time we proved a formula describing the capacitance of a capacitor in terms of its size and in terms of the material between the plates of that capacitor. And the formula was something like this. The capacitance of a capacitor is proportional to the surface area of the plates. You take only one of the plates, not both of them. Proportional to electric permittivity, proportional to the dielectric constant of the material between the plates, and inversely proportional to the distance between the plates. So this is the formula that we derived for capacitance of a capacitor. And in problem number 22, they tell us apply this formula for the case when the dielectric constant kappa is equal to 5. The distance between the plates is the thickness of the membrane, this number, 10 to the negative 8 meters. And they have to give you the area of the membrane, the total area of the membrane is a different number for different people, but it is given in square meters, so you don't need to change units anywhere here. So plug in those numbers, and you're going to get the capacitance of this capacitor. Again, use significant digits, more significant digits, so that WebAssign to accept your answer. So the answer is just this number. You have to read the electric permittivity from a table, and everything else is given. Let's see questions. So I don't like problems of this type because they are problems of the type take a formula and plug in numbers. This is not how you do science. But I gave this problem because it is related with biology, and biology is the field of study that most of you have chosen.
Someone asked a question.
Yes.
So the A value will be found in the table in the textbook.
Which value?
The A value.
Oh, the area. The area is given in the problem. For my version of the problem, the area is 4.5 times 10 to the negative 6 square meters. For your version of the problem, it is going to be slightly different number. This is the total area of the membrane. And they model the membrane as if it is two layers separated. And the membrane, cell membrane is two layers, right? Two lipid layers separated by some material, protein material usually. And they give you the dielectric constant of that material. You have to treat the membrane as if it is not made of layers of lipids, but as if it is made of metal, like two metal plates. So it's a model, but it is quite accurate model actually. And if you want to make it more accurate, you have to do some measurements of the neuron. Okay. Other questions? No? Okay. So we have plenty of time to discuss any other questions that you may have. And if you don't have other questions, I have some conceptual questions, simple conceptual questions that you can treat as a quiz. You can answer those questions by raising your hand. For answer A is this, answer B is this, and so on. For people that are online, feel free to answer by using the chat function and answer again, either with A, B, C, or with 1, 2, 3, 4, or whatever. So those quiz questions, I'm going to eventually post those files. So you're going to have access to those files when you are preparing for a test. So let's start with the questions. The first question probably. So we're going to show those questions. If I had them on this computer, but I don't have them right now on this computer, so people just have to look. Yeah, we need this right here. So the first 2 or 3 questions are kind of questions that you have seen before. But let's go over them again. We have seen questions of this type before. So to answer this question, just the only thing that you need to answer this question is the definition for electric field. We define electric field as the force acting per unit test charge, positive test charge Q. But we said, well, we use this definition very often in other way. We use it to calculate the force. So the force that acts on a charge Q, positive charge Q, is going to be a product of the charge times the electric field. And in this problem, they're asking about magnitudes of forces, so you can take absolute value and get rid of, not think about negative charge of electron or whatever particle you have. So here is the way to think about this problem. The magnitude of the force is equal to the magnitude of the product of the charge times the electric field in which this charge is located. So what would be your answer? 1, 2, 3, or 4 or 5? Yeah, go ahead. This is how you earn. You cannot make a mistake here, and you can always earn some brownie points. So look, the charge of the electron and the charge of the proton are the same in magnitude, right? The electric field, they say, is everywhere the same. So the product of those two is going to give you exactly the same force in magnitude. And of course, the positive charge is going to be attracted to the negative plate, and the negative charge is going to be. So the directions don't matter, they just want the magnitude of the force, and the magnitude is the same, clearly. Okay, let's see. So the next question is similar, but now they're not asking about the acceleration. And of course, acceleration is practically force per unit mass. So you apply the same force either to a massive proton or a very light electron. Which one is going to accelerate? So this is the same. You have either very large mass of the proton or you have a very small mass of the electron. Which one has to be to accelerate to a larger, with a larger acceleration in order to get the same product, the same force? Okay, so clearly the acceleration of the lighter particle of the electron is going to be larger. The proton, not so much. Yeah, this is the thing. Yeah,
This isn't ideal.
yeah, it is far from ideal. I probably, yeah, I can, yeah, well, I can try to download here, but it is going to take time. It's not going to work very fast. Well, for the moment, just try to do best as good. People that are online, just try to read from the screen, and if you cannot read very well, those files, eventually you're going to have access to those files. Okay, another question, similar.
Someone had a question online.
Yes.
They're talking about this formula right here.
Which one?
About the dielectric constant.
Yes.
They were wondering if E naught and the dielectric constant are.
So E naught and dielectric constant are not the same. So epsilon naught is electric permittivity of vacuum, of empty space. And in order to describe materials that are not vacuum or air, you have to, so this expression expresses so-called electric permittivity of your material. So the product of epsilon naught times kappa is Kappa is a unitless number. Dielectric constant is unitless number. It tells you by what factor you have to change to account for the properties of the material rather than empty space. Okay. Other questions? If not, let's go back to here, to the conceptual question that you see there. Here, you are asked to figure out the kinetic energy of the proton or the electron. And look, it is exactly the question that we had in the homework problem. The work of the electric field is kinetic energy. The charge of the electron and the proton are the same. The voltage difference between the plates is also the same in magnitude. Therefore, the product is the same. Therefore, the kinetic energy that they acquire is going to be the same. Even though the proton is moving much slower, it has much larger mass, and its kinetic energy is going to be the same as the fast-moving electron with smaller mass electron, of course. So again, the formula is exactly like the solution to problem, I think, what was it, 18, or one of the problems that we solved from the homework assessment.
You had another question in mind. They said, what is kappa value?
The value of the dielectric constant is given in the problem. So kappa, in the textbook, they use curly K-like symbol for the dielectric constant. But the problem gives you the dielectric constant of the material between the two lipid layers of the membrane. They give you some, for my version, it was the number 5. So kappa is 5 for my version. And I don't know what is, if it was randomized for different people or not, but it is just a constant number that you read by reading the question in the homework assignment. Okay, other? So it looks like people that are online have many questions, and people that are here don't have any questions.
You have another question.
Okay.
And is the thickness the distance?
The thickness of the membrane is the distance d, yes. And it is given again in the problem. I don't remember if it is randomized or not, but in the problem it is given in meters, so you don't have to do any conversion. Okay, other questions? So it looks like this neuron problem was created, well, multiple problems, not multiple questions. Okay, now let's go back to the conceptual question on the board. Which one has more kinetic energy, the electron or the proton? What do you say? Yeah. So the argument, they must have exactly the same kinetic energy when they hit the opposite plate, because of the homework problem describes the reasoning pretty well. Well, here I say work, they say potential energy. It's the same. Okay, let's look at the next question. So they are practically here asking you, what is the electric potential energy of certain configuration of charges? Configuration 1, configuration 2. And to answer that question, remember the basic formula for electric potential energy of a system of charges, point-like charges. The formula was like this: electric potential energy of a system of two charges is equal to the constant of proportionality times the product of the two charges divided by the distance between them. So here is charge Q1, here is charge Q2, point-like charges. The distance between them is this distance R. This formula gives you the electric potential energy of this configuration of charges. Charges have to be taken together with their algebraic sign in this formula. Now, the electric potential energy of a system of more point-like charges, you calculate by taking each possible pair. So the electric potential energy of three charges is going to be K times Q1 times Q2 divided by the distance between them, plus K times Q1 times Q3 divided by the distance between charge 1 and charge 3, plus K times Q2, Q3 divided by the distance between charge 2 and charge 3. Here in this formula, if this is Q1, if this is Q2, and if this is Q3, this is the distance R12, this is the distance R13, and this is the distance R23. So now, knowing this, you can, which one is larger? Okay, so clearly, when you use this formula for the three charges, you're going to get what? You're going to get the number 3 times constant, times some constant. Well, for the first configuration, you're going to get the number 2, and clearly 3 is larger than 2. So the second configuration wins. They give you the arithmetic that. Okay. Go to the next one. So now you have two sources, and they're asking you to figure out what is the voltage at some point A. And to answer that, here is how you do the reasoning the following way. The voltage created by one charge is constant times the value of the charge together with its algebraic sign divided by the distance between the charge and the point of interest. In my case, in the case on the board, you have two charges. So the first charge Q1, so the total voltage is going to be K times the first charge. Q1 is negative 50. Negative 50 divided by the micro, right? So everything is micro. Divided by the distance between that charge, and so that distance for me is 0.6 meters. And after that, you have another charge, but it is positive 50 divided by the distance between the second source and the point of interest now is 0.3. So this is the net voltage at point A, assuming, of course, that the voltage at infinity is 0. So when you add those two numbers, are you going to get a positive or a negative number? K is a positive constant. So you're going to get, so what is your, yeah. Any other answers, please? Negative. So when you divide to a larger number, you get a smaller result, right? So it should be positive. Good. You just do this arithmetic and you're going to convince yourself how it works. Oh, now they want you to do a similar calculation for the potential at point B. And you want, yeah, but look, for point B, you don't even need to do the arithmetic actually, some people actually. So don't hurry, look. You have positive voltage generated by the red charge. This distance is exactly the same as this distance. And this is exactly the same charge, but with negative number. Look, you're going to have positive voltage from this one, from the red, exactly the same, but negative voltage from the green charge. And therefore, just because the distances are exactly the same, look, they say that this perpendicular divides into two equal distances, which means that you have equal triangles and so on. So you can make the argument that the distance between the red and point B is exactly 40 centimeters. And therefore, one voltage positive, the other negative, the net voltage at point B is going to be 0. Right? That's. Now we're running out of time. So this is slide number 12. Please remind me on Monday we to go over the remaining how many 5-6 slides, 5-6 questions, because they're important before we start with chapter 20. Read chapter 20. It is much easier, much less abstract chapter. And chapter 20, after we finish chapter 20, which we can do very fast, we're going to be ready for the picture. So let's end here. Let's see questions and remarks.
Yep, they just wanted to make sure that there's, as of right now, no set date for the first exam.
So the first exam, no particular date, but it should be the week after next week. It should be the week after next week. It could be Monday, Wednesday, or Friday. The week after next week. Okay. Are there? In that case, we're going to continue on Monday. Have a nice weekend.